Welcome to This Explainer. Look, today we're doing things a little differently. We are totally stripping away all the bloated, heavy theory you usually find in traditional coding courses. Instead, we're zooming in entirely on the visual, interactive, play-first method of Python programming. We want to skip the textbook and get you straight to the absolute best part, actually making things move on your screen.
Okay, so let's dive right into our core philosophy for this, which is not theory, just the pieces you'll actually touch. This right here is our anti-theory hook. We're only going to focus on the literal levers and dials you need to start building, moving, interactive projects today. You really don't need a computer science degree to start playing around. You just need to know what to tweak.
So Section 1, Play First Python Vocabulary. We're going to build this up block by block.
We're starting with the absolute smallest conceptual piece you need to know, and that is the variable. Think of a variable as just your project's memory. Literally, it's just a name that remembers a value for you. And the beautiful thing about Python, you don't even have to declare complex types. You just assign a value to a name and boom, you immediately move on to the fun stuff.
The crucial takeaway here is that variables are exactly where you get to act as the director of your code. By just changing a simple number or a string of text, you're constantly tweaking star speed, ball size, a message text, maybe the gravity strength, or even the defaults on a chaos slider. Everything fun and customizable lives right here in variables. You change one value, and suddenly your entire project transforms. It's kind of like magic.
Moving right along to Section 2, Memory and Groups, how we go about storing a galaxy.
Now that we have those awesome single memories set up with variables, how do we store a whole galaxy of items? Well, that brings us to lists. A list is essentially a container holding multiple values. And honestly, this is exactly the tool you're going to reach for when handling particles, bouncing colors, or absolutely anything that moves in a group across your screen.
For example, in a project like drifting stars, every single star isn't getting its own separate, uniquely named variable. That would take forever, right? Instead, they're all just stored in a single list. And because they're grouped together in this one container, the game loop can efficiently look at the list and update every single star frame by frame all at once.
Which perfectly leads us to Section 3, the heartbeat of animation, better known as the game loop.
Now this game loop is where the magic really happens, where we inject actual life into those static lists. Every Pygame project runs inside one of these. I want you to think of this loop as a biological heartbeat. With every single beat, it updates positions, it checks to see if you've clicked a mouse or pressed a key, and then it redraws the screen. It is constantly working behind the scenes to bring your code to life.
And you know, this brilliantly illustrates the difference between traditional web programming and game programming. If you think about basic HTML, it's pretty much just refresh the page when you want to change. But Python animation, it's refresh the entire window 60 times per second. We aren't just loading a static page anymore. We are generating continuous, fluid motion.
To mimic that heartbeat we just talked about, Pygame is rushing through that loop to refresh your window a blistering 60 times per second. That rapid, continuous redrawing is exactly what tricks our eyes into seeing smooth animation instead of just a clunky series of still images. Now, to keep things organized while your computer is running at that blistering speed, we use functions. Simply put, a function lets you name a behavior. It allows you to group a bunch of individual steps together into one neat little package and then reuse them whenever you want, whether that's drawing stars, updating motion, or handling collisions. By grouping the steps for a behavior, like, say, moving a star, you save an incredible amount of time. But here's the absolute best part for a play-first programmer. You won't even need to write many of these functions yourself from scratch. Modern AI can generate all the boring boilerplate for these behaviors. Your job is way more fun. You just jump inside the function, tweak the speed and drift numbers, and get the exact visual effect you're looking for.
All right, Section 4, Reacting to the World. This is where we add a little intelligence.
So, we have our building blocks, and we have motion, but now we need to grant our creation a tiny bit of intelligence so it can actually react to things. This is where if statements come in. They are the ultimate decision makers of your code. They're what allow your project to respond to conditions, making decisions like bouncing a ball off of a wall, changing colors dynamically when items collide, or maybe triggering a chaos equalizer. And the logic here is beautifully simple. Check this out. If a star's x-coordinate gets greater than 800, meaning it literally just flew off the right edge of our screen, we just reset its position to 0. Boom! It instantly reappears on the left side of the screen. With literally just 2 lines of code, you've created an infinite wrapping universe. How cool is that?
Bringing it all together in Section 5, the moving dot. This is your very first project.
By stacking these 4 exact steps, you create a complete working script. First, you set up the Pygame screen. Second, you define your memory, so that's your x-coordinate and your speed variables. Third, you start up that heartbeat loop. And fourth, you tell it to draw your circle, updating the x-coordinate by the speed every single frame.
When you run that simple script, you are rewarded with exactly this, a glowing dot sliding smoothly across your screen. Now, it might seem super simple at first glance, but trust me, this is your ultimate warm-up. This sliding dot is absolute proof that you now possess the core building blocks for every single project in the book. You understand memory, groups, loops, and decisions.
You are no longer just sitting back reading theory, you are actively in the driver's seat. You've touched the levers, you've turned the dials. So, as we wrap up this explainer, I'll leave you with this one thought. With these powerful play-first tools now right in your hands, what kind of universe are you going to build next?